Multiple aspect colour light signalling uses either glass or polycarbonate outer lenses with an inner coloured lens of red, yellow or bluey green to provide the filtered colour that required from the lamp inside. Modern aspect colour light signals are proved to have a lamp illuminated to allow the signalling rear to be cleared. This uses a lamp proving relay which takes some of the current that feeds the lamp, which is shunted through an internal resistor and goes down into a diode unit that converts the AC to DC to drive the relay. A slug is provided on the coils of the relay to prevent the lamp from, as when it changes aspects, from chattering the relay and dropping the relay out, causing the signalling rear to go to danger. So here we are in Staffordshire at the Foxfield Railway to have a look around the signalling here with our host today, Mr Ashton. I'm going to have a look around, see the box here at the main base, and we're going to see what else they've got on the railway. So here we are at Cavelsall Road on the Foxfield Railway with our host John Ansett. Hi John.
Hello.
And John's going to talk us around the box and how it works and what it controls. Off you go.
Okay, so I'm John Ashton. I've been here about 50 years, Foxfield Railway. Do a lot of work under Ron Wally, a lot of people will know. Been doing a lot of work for Ron with the signalling, and with the new system we put in. The railway was originally on semaphores and 3 aspect colour light signals, and we ran 3 aspects with green for main route, yellow for subsidiary, red obviously for danger. So about 6 years ago we embarked on a re-signalling project for the whole area. That was removal of semaphores and installation of colour lights with route locking. So the route locking we've now got involves a route locking lever, acceptance lever, which is number 3. So any routes that come inbound, when we set routes up, we pull number 3, which clears signals, allow signals to be cleared. And once number 3 has been reversed, we cannot reset the route until we have the tyres key back in. So if a train is out and has a tyres key, if we've cleared a route to come inbound, we can't reset any routes until the train's back in and we've received the tyres key.
And that key goes with the driver of the train?
That's with the driver, that is to staff.
And this unit, John, where was this made? Was it the lad from JCB?
It would be a lad from JCB that made that, yes.
I believe he made one for the Churnet Valley Railway as well.
Yes.
So it's a brand new handmade unit. We may have a look in that later, just to have a look how it works. Can you explain how the frame works, please?
So so the frame wasn't original in the signal box. Now this signal box came from Hockley Crossing when I was a very, very young lad. My family actually worked within the signal box in Uttoxeter, and so I know this box from very, very days of old. So this box was brought to Foxfield Railway, rebuilt here on brick base. The lever frame you can see is actually part of the original Stoke-on-Trent emergency frame from the war. It was in 2 pieces, 2 20 lever sections. One was installed here, the interlocking done and installed. So basically how we run now is if we've got inbound trains, we have main aspects for the inbound routes. So starting with number 1, coming into a number 2, and then we come, not main aspect signals, but we use these for route indicators, which we'll talk about in a bit. So number 9 and number 10 to bring us straight in to the main platform. The area currently signified with A alphas has not been installed yet. That's work ongoing. So normally for an inbound service, we just simply route is set, so all point work is normalising the frame, all FPLs are normalising the frame as well. So just standard operation for coming inbound is just number one, everything's electrical again, but you'll probably notice lever top has not been cut down from semaphores. So it's just 1 and 2, got 9 and 10. So we then use number 3. So at the moment, we've got number 1 signal that's been cleared, 9 and 10 have been cleared, which
Yeah,
10 is just that side.
You see that there?
Yeah.
So just looking at the diagram here, John's just about to tell us a few things that are coming in the future. We've noticed there's some push buttons to be installed on the platforms. They're not in yet, but they will be installed. And one thing we've noticed straight away, obviously, colour light signals, as you can appreciate. That's number, let me get this right, that's number 3 just there on the corner, John?
Number 2.
Number 2, sorry?
The aspect is 2.
2.
And the locking lever is 3.
It's 3, right. And that's just there, you can just see in the finger. But you notice on the block shelf, there's no indications for the signals. And obviously the colour lights with our backs to us. And John has just explained that at some point in the future, their interlocking, which is there, is pre-wired to allow the route setting lights on the panel for your indication. Instead of having separate lights, you can put them on the panel. It is fully track circuited. And do you want to take us through anything else, John, that's going on the panel in the next few years?
Yeah, so you mentioned about track circuited. Well, there's no actual track circuits on the ground, but with the white lights are going to be due for the route.
Yep.
So whenever any route's selected, it'll be done through the relays inside,
yep.
Repeated onto here, so you can see what route has been set up, which does come in useful for if you've lost an indication on points or something. It will actually
tell you where it's failed up to.
This bit we haven't got an indication, or if you're looking for the fault, you know it's around this area or that area, which is very handy. So yeah, you mentioned things that are not actually in currently. So we've got here, these are showing indications. What these will be release plungers. So when we set a route for a train to come in, we want to be able to not allow the signalman to reset the route until the train is incomplete. So with us working here staff and ticket system, so we've got the tyres key as a staff, but we also run tickets. So if we've got a first train arriving with a ticket only, the issue then comes, we haven't got the train staff, the tyres key, to reset the route for the next train. So the idea that Ron came up with was we put route release plungers on the platform. So when a train arrives, the guard, it'll be his responsibility to open the cabinet up, plunge to release the route, which will then release number 3 when it's out of the frame. So if number 3 is out of the frame now, if the train was out, then the key would be out with the driver. So that would now mean number 3 is locked. So we cannot change any points under any train.
Yeah.
So if train arrives, whether it will be in the loop, the platform, the bay, one of these will relate to each route. So the guard comes in, plunges when he's arrived, and that's base confirming complete with tail lamp, and he's arrived. So we know then nothing is over any point work. What that will then do, in essence, I'll show it with the key. The key wouldn't actually be in at this point, could still be out with the second train potentially. So what you do, the guard would press the plunger and you get the F. F for free. So as soon as you've got the free, that allows you to then plunge
and put
the release back. So
just looking at the lever frame here, I see that is this Ron's idea to use mag switches on the back of the tails. What voltage are they? Low voltage? Low voltage. They drive the control relays.
Yes, so basically, they are detecting for all the relays
in your interlocking.
In the cabinets, yes.
We'll have to have a look at that interlocking in there. I like that's a nice little money saving, time saving idea, that with some modern technology that it can easily be replaced, and it's just mounted straight down to a horizontal bracket that runs along the back of the frame, so they can easily be changed if they need to. There's the mechanical points in advance of the inner home, and I like how they've done the detection here. They've used signal contact boxes to prove the FPL and prove the position of the points. That's something different. So here we are at the starter heading towards Dilhorn. That's the furthest signal out, number 18, and as you'll notice, it's made using some integral optical units out of one of the LED dorm and ground signals. It's a nice little build there with some Dorman covers on them as well. Good sighting. You can see this from the box. It's incredibly bright, and John was telling us it's very bright at night, in fact. And we'll see this signal being cleared now. And there you go. We have a top green and back to a red. Quite an effective little home build installation there by the railway itself. And if we just turn around, you can see the other signal there. That's a traditional aspect signal with that's the inner home, and just in front of that, we're going to have a look in a minute. The line diverges two directions there. We'll explain that in a minute. Now here we are down at the inner home, and you'll notice the line just in front of us here goes off towards the left down to the colliery sidings. It used to be at the main line down there, and right it goes around into the station, which is controlled by the signal box here. And here we have our inner home, we have our main aspects, and we also have our subsidiary there, which John will clear for us now and show us. Get our yellow. And you have the sub route for down to the bottom line there. The points are detected off a BR standard electrical detector. So we'll have a quick look at that. John's just clearing it there again for us. Now, as you can appreciate, as you look at this, you'll notice that the hotspot is on the, what I would say is the 8 o'clock position, facing towards the line here. Traditionally it's on the 5 o'clock position, signals are mounted to the left, but as you can appreciate, this signal is mounted to the right here for sighting purposes. So our hotspot, which I've mentioned before, is pointed down here towards the driver's eye level. If John puts the signal back to red now, you'll appreciate this. Wait for it to go back. What we can do, if you imagine a driver is underneath this signal here, his sighting may be impaired a little bit once you get out of the focal length of that. But if you look there, you can see there's a nice bright strip of light shining down towards the driver. So if the driver was literally right at the signal, at the side of it, you still have a good clear view of that light coming down through the hot strip there. And the focus beam at the front. The old EB ground signals here, which are used, glass lenses, a lunar white outside and blue, and also there's inner lenses as well. Not much focusing on these, but they are used primarily for close sighting, and you've got your drain holes on the bottom there, because obviously one of the problem with colour light signals is not much heat in these lamps. If they're not lit all the time, you get a snow build up, which is what the covers on heads are for, and also to block out extraneous light. And this little bit here can build snow up, but not enough. But you've got your drain hole there to let it melt off. John's just been telling me that the aspects used out of this were out of Dorman miniature red-green crossing signal?
Red and green crossings.
Red and green crossing.
Red and green crossings.
Quite a nice little build that. It's very compact. Daft little question. What's that little hole on the side for, John?
Hole on the side? They've all got the holes on the side.
Any idea what they're for?
No idea.
I haven't got an idea either, but we will find out off our members. So this is number one, our outer home, John?
Outer home, yeah.
Outer home. Currently at green, because the signal, I don't know if you can just see it, down there that we were at previously is that single yellow aspect. Used to be a semaphore signal, I can see.
It was a semaphore, so we reused the post, yes.
It's nice and high up. You don't have any problems with vandalism around here, do you? So
we used to. It seemed to have got a lot better over the past years.
I was going to say, because normally you can get the mesh heads, can't you? The chip pans, as we call them.
Yes, yeah.
There's a nice bracket. I like the homemade bracket on that. That's quite nice. That good sighting all the way back. And I don't know if you can see back down here, folks, but just down there. What's the name of the crossing?
Creswell Ford.
Creswell Ford. It's right down there. You can probably just see the semaphore in the distance there, protecting the crossing. Little one here for the P-Way institution. trial plastic sleepers by a company, John says, in Utoxeter.
Somewhere in Utoxeter, yes.
Nice bright and orange, so the tampers won't hit it. Have a good laugh. Yes. Yeah. That's an interesting design.
A shunt signal as well.
This is what we would call a running shunt signal, because it's in advance of the inner home, if I've got that right, and it's just approaching the station here. There's the sidings line off to the left or right, John? To the right, and then the station line follows around to the left. And if you notice, they use it as route setting, so it's telling you which way you're set here for your points. And you can see the other one down there, just past the signal box there, is telling him the route set to the left, to the right, sorry, yes, the right into the platform there where the tall signal is. So a running shunt, another running shunt used as route setting. So John's going to tell us now about the king lever and what purpose that fulfills.
Right, so yeah, so we've got what we call a king lever, which allows us, when we're running one engine in steam, to allow the guard to act as signalman. So what we can do, we can set the route like we did previously with number 3, which selects the route and locks the route. Now, providing the tyres key is in the instrument, we can reverse 13, which then allows interlocking, set the route to go outbound. Taking the tyres key out locks the system. So now we've got the system set for train to depart and for train to come back. So
it's set the outbound and the inbound signals together now and close the box out.
That's right. Driver takes the tyres key as the train staff and off they go. Come back and the guard brings tyres key over, runs the train round, resets the route again, and off they go for a second train.
So here we are in the interlocking here at Foxfield Road, and what we have here is octal relays, standard octal relays. John's just been telling me little telltales on the front, so you can tell whether they're up or down, fault finding, and we've got 2 cabinets here. And we have our, as per standard, HR, so yellow relay for number 1 signal, signal relay for number 2, and position light relays, PLRs. Nice little interlocking that, John. Anything else you want to tell us about it?
Not really, no. No, it's very self-explanatory, I'd have thought.
It's very
a very minimal space-saving idea that Ron came up with, and very well designed. Works well.
Nice and tidy little installation as well. Going to have just a quick little look inside the key release instrument here. Now, it's made by one of our colleagues who used to work at JCB, that makes the big JCB diggers. Modular design based on the tyres lock. Sections come apart with all the bits of the actual plate work inside that react to the keys. This one's fitted out with an electrical microswitch. We have another one at Churnet Valley Railway, but that one's slightly different. That one's just contacts inside, it doesn't have a lock inside. And obviously when you put the key in, it reacts to a set of contacts. But very simple design. Everything's welded up to stop you getting into it and getting out of it. John's going to show us it with turning now. Makes the micro switch. Breaks the micro switch.
The rim tap, 2 reds in it.
Yeah, John's going to show us through some of his recovered LED ground signal units here that they've altered to make their signals around the railway and how they've done that.
Someone's going to make some room.
So that's the standard unit that would come as prepared. It folds out the back, doesn't it, John? Of
It does, yes.
The mounting that it's in the track with. And as you can see, everything's integral. These do come apart. Are they screwed from the back? I can never remember. Ah, yes. So
yes,
they're bolted in. 110 volt units, pre-wired at the factory, and then they just sit in the mounting plate. The access cable comes up from inside. It's treed off on this 6-way to standard 2BA terminal block. And then if you need to maintain this, as you unwind the handle that's in the back that goes into there, the unit just falls out like that, so you can maintain it. Very little maintenance on them though, because they are sealed units. And you've been adapting some of these for your railway, John?
Yes, that's right. So it was an idea, again, through discussion with Ron, we came up with how to do the route indication and also use them for shunt signals. So the normal lay of the signals is, as you see, the main line would be 2 reds across the bottom for the standard stop and 2 whites for the proceed. So with what you've seen already, how we've used the 2 whites for route indication for the left or to the right. So what we actually did, the individual light units, which is one of these, all removable. So you've actually got white, red, or white and red.
Yeah.
So basically, as you'll see outside, we use single red only.
Yes.
So we move the red and white that was from the bottom and put into the top. So we just get a single red aspect.
Yeah.
And then we basically we have to use 2 signals to make one.
Yes.
Whereas normally you've got 1 white only, and you have a red and white and a red. So to make this actually work, we need the 2 whites and the red and white.
If we just look at the unit, because unless you see these really close up, you don't really appreciate it. The optical assembly itself has, depending on which one you manufacturer you get, the LEDs can fail up to a certain amount, and the rest will still continue to work. And I think I know there's on a lot of the LED units now. The early ones used to suffer because there was not much heat coming off them. You would get build up on snow. But if you notice very carefully, it's angled. So a build up of snow is not going to happen on an angle, so it'll fall off. But also a lot of them have, if you mount this up at a particular angle towards, say, the eastern sun coming up, I mean, you can just get an example there, that's the light behind me in the container. You could end up having a phantom aspect where the sunlight bounces back off the LEDs, because the LEDs are in effect miniature reflectors, and they'll bounce light back. And I know some of the early designs, so yes, some of them had LED burnout. There's an internal assembly, so if you can appreciate, if you've got sunlight shining in on this all day, you can end up burning it out. But also, these are miniature reflectors, they're already reflecting light in the container here around us. So you have to angle these, and the base plate that it's mounted on is pre-angled, but if you mount these at the wrong angle, you can end up doing that and reflecting phantom aspects back. There's a signal actually near Stockport that's not in use. It's a training signal, but it does just that from one of the road lights.
Yeah, because I know on all of them, they are actually labelled up on the signals themselves when they're pre-built. It's lower or upper.
Yes.
So obviously, if some are like treating as cat's eye shunt ahead, mounted above,
yes, yeah.
or some are ground mounted, they're actually set up differently.
Ah, very clever.
It's actually the pre-labelled up.
That's inside of one of the units, as you can see, nicely sealed. And that's the back mount.
Yes.
So if you were to unscrew that, this back would fall off with these optical units attached to it. Those are the standard Dorman units. Thanks very much for that, John. John was just showing us these long hoods, which are the standard hoods to go on here. Quite long, so obviously you're not going to get, when this is mounted at ground level, you're not going to get much light creeping in from, say, the sun angle to give you that phantom aspect with those longer hoods. And also you're not going to get much build up there either of snow in the end of the hood. That's important. So John will just show us that mounted on there. So you've got a fair way you can angle that back and still not have a phantom aspect from the sunlight.
And obviously this is done with the front cover on as well.
Are most of your, which way is your north, east, south, west here? Do any of your signals face towards the evening sun, morning sun? You're quite safe on that?
We do get, when the sun comes down in the evening, the ground position light that's in the loop, the sun can at certain times of year come straight down the loop, straight into it.
And those will guard against that then?
Yes, at the moment we haven't got the long hoods on.
Yeah.
We've got the standard signal, but you can see the actual signal, you can get like the grey aspects.
Yeah.
You can actually show, instead of being the pure white,
yeah,
you look down, you can see like a grey aspect.
That's just starting to get into it.
So we're putting those hoods on, that's the plan, is to stop that completely. But then of course the problem then from steam locos drawing up too close,
yeah,
you can't see them.
See that then.
So you end up angling them up more, or you got to ensure that the drivers stop further away.
You can almost do with like the London Underground had, or the Irish Rail, where they've got the side aspect when you pull right up to it, like a little telltale.
Yes, see from the side, yes. Yeah.
Well, I'm just here with John. This is Hockley Crossing, which is a signal box at Campbell Road that we're looking at. That's a photograph of it as it was in its original place, and which leads us nicely onto this, which we've just spotted here as well. Now, I forget the term, John, sorry to say, but basically what you have is a pair of 110 volt lamps. So you light both lamps and they illuminate through a front indicator, which it was Nazing glass, which is a blue glass made locally in Stoke-on-Trent area and a few other places. Bit hard to get hold of now. Various railways have done it different ways with perspex and different glasses over the years, but you have a painted stencil on the front and the light shines through that. Sometimes the stencil's on the inside and the blue Nazing glass is on the outside, which prevents reflection of the light, etc. And importantly, if you've never worked on these before, they are keyed, so you can't get the wrong stencil when you take these off for maintenance back on the wrong router. There's a little tiny metal pin there which fits into a groove, and the one above it should have a different groove, different pin configuration, so you can't get them wrong. And again, these can have mesh fronts on as well, so if you've got high vandal areas, places damaged, you can fit them out as well. And if it's even worse than that, you can have metal box frames with more mesh so it stands off the front of them. A lot of limited shunts are fitted with them nowadays. One thing John was showing us, and this takes us kind of to the modern era really, in most 7.4 signals you had a 12 volt 24 watt dual filament lamp, which we discussed earlier in the film, and this is the modern replacement. This is an LED light engine, so all integral components, the LEDs there to give you the various colours, so you have reds, yellows, greens, you can have whites, it depends on the circumstances. It still fits the 3-pin base for the SL35s, so they're just in and clip, and then you have some flying leads to put through to the actual terminals on the back. Some, I'm not sure, but some were, they did have earlier problems with the current draw for the lamp proving, but being as they're an LED, you know, the life cycle on these is quite long compared to an SL35 lamp or an 8,000 hours lamp. So certain places that's not actually required. It depends on your circumstances. But these are some. You've been fitting these down the railway as well, haven't you?
Yes, yeah. These are the Mark IIs, I think they were. Became obsolete. I think these were the ones that were freezing up. So
yes.
If they weren't used for a duration of time, they'd freeze up and the aspects couldn't be changed within. So and susceptible to the cold.
So I've driven off some IC chips there, I won't touch. Some integral discrete components there. And a big resistor on the back to draw the same current. So just looking at the diagram here, John's just about to tell us a few things that are coming in the future. We've noticed there's some push buttons to be installed on the platforms. They're not in yet, but they will be installed. And one thing we've noticed straight away, obviously, colour light signals, as you can appreciate. That's number, let me get this right, that's number 3 just there on the corner, John?
Number 2.
Number 2, sorry.
The aspect is 2.
2.
And the locking lever is 3.
It's 3, right. And that's just there, you can just see in the finger. But you notice on the block shelf, there's no indications for the signals. And obviously the colour lights with our backs to us. And John has just explained that at some point in the future, their interlocking, which is there, is pre-wired to allow the route setting lights on the panel for your indication. Instead of having separate lights, you can put them on the panel. It is fully track circuited. And do you want to take us through anything else, John, that's going on the panel in the next few years?
Yeah, so you mentioned about track circuited. Well, there's no actual track circuits on the ground, but with the white lights are going to be doing for the route.
Yeah.
So whenever any route's selected, it'll be done through the relays inside,
yeah.
Repeated onto here, so you can see what route has been set up, which does come in useful for if you've lost an indication on points or something. It will actually
tell you where it's failed up to.
This bit we haven't got an indication, or if you're looking for the full, you know it's around this area or that area, which very handy. So yeah, you mentioned things that are not actually in currently. So we've got here, these are showing indications. What these will be release plungers. So when we set a route for a train to come in, we want to be able to not allow the signalman to reset the route until the train is incomplete. So with us working here, staff and ticket system, so we've got the tyres key as a staff, but we also run tickets. So if we've got a first train arriving with a ticket only, the issue then comes, we haven't got the train staff, the tyres key, to reset the route for the next train. So the idea that Ron came up with was we put route release plungers on the platform. So when a train arrives, the guard, it'll be his responsibility to open the cabinet up, plunge to release the route, which will then release number 3 when it's out of the frame. So if number 3 is out of the frame now, if the train was out, then the key would be out with the driver. So that would now mean number 3 is locked. So we cannot change any points under any train.
Yeah.
So if train arrives, whether it will be in the loop, the platform, the bay, one of these will relate to each route. So the guard comes in, plunges when he's arrived, and that's base confirming complete with tail lamp, and he's arrived. So we know then nothing is over any point work. What that will then do, in essence, I'll show it with the key. The key wouldn't actually be in at this point, could still be out with the second train potentially. So what you do, the guard would press the plunger, and you get the F. F for free. So as soon as you've got the free, that allows you to then plunge
and put the
release back.